Let's talk about ACLs. So ACLs are at the core of the access control model in Active Directory. The way ACL works in Active Directory is think of it as it would have two parts. Okay, before giving an example, a process would have an access token that contains its identity and privileges of the user and the object that you're trying to access. It would have SID of the owner and two lists, a discretionary access control list or DACL or a system access control list or SACL. So it is pretty similar to, let's say, when you check into a hotel, you are given a key card. Now the key card may have, or a better example be your office identity card. If your organization uses RFID cards, where you when you touch the card to a reader and get access. So what does the card have? It has your identity and your privileges. That is, you can access your own office area, you can access cafeteria, but you can probably not access the CEO's cabin, for example. So when you present that card to a card reader, the card reader would have lists. Who is allowed to access? Does your name show up in the list? If your name shows up in blocked or denied, that takes precedence. And then it may or may not log your access. That is almost exactly, super simplified, but almost exactly how ACLs work. Whenever a process or a thread wants to access an object, the object has a list where it matches with the identity, whether the identity provided by the process has access or not. So what is that list? It is called the ACL or access control list. Each of the entry is called ACE, access control entry. There are two types of ACLs. DACL. DACL defines what is the access that you have or not. And SACL logs success or failure. That is the difference. DACL controls your access, SACL logs your access. So for example, let's say there are two threads, thread A and B, and thread A wants to access an object. So thread A has an access token of a user Andrew, and Andrew is a member of three groups, group A, B, and C. So the access token would have privileges of the three groups as well. The thread presents that to the object, and then the system starts checking the DACL. On the very first ACE or access control entry, there is an explicit access denied for Andrew. Deny takes precedence, so thread A would have their access denied right away. Now, when thread B tries to access the object, let's say it is a user, it has an access token of user Jane and a group A. So the thread tries to access the object. The first ACE doesn't match because it is not applicable to Jane or group A. The second ACE matches, it is applicable to group A. They have write permissions. The third ACE allows everyone read and execute permissions. So effectively, what thread B has is read, write, and execute. All right. That is how ACLs work. I could see your question, someone, but I'm not going to answer it. That would be too complex for the discussion right now. Okay. So this is how ACL works. Sorry. So what does that mean? That means that, okay, I have another diagram for you, which I've not yet copied. Just give me a moment. I'll share that in the course one drive after. Just give me a moment. That is specifically for ACLs. This one. I'll share that on the course one drive. I'll just ask my team. Just give me a moment. Oh, I'll do that. I'll do that. Let's not go into that. Let's first take a look at this. So what is it that you can do with ACLs? A lot, a lot. So generic all is the take it all role. Of course, this is equivalent to full control. So if you have, of course, generic all on an object, so the way this diagram is, what is the permission, what is the object, the target object, and what is it that you can do? So for example, let's leave generic all. Let's say if you have generic right over a user, what is it that you can do? A lot of things. We've tried to be comprehensive, but of course we might have missed something. So what is it that we can do on a user? We can reset their password. We can go for targeted Kerberos. We can set up shadow credentials. We can set up login scripts. No login scripts. That's a mistake. These two are covered in the course. All right. Similarly, if you have all extended rights, some specific rights on a user, you can probably reset their password. If you have, let's say, write decal on the domain object itself, you can run DC sync or you can get generic all, and so on. So this diagram, which I'm going to share just after the class, lists what is it that you can do with the ACLs. And that simply means ACLs, how important ACLs are in Active Directory. So do we understand the importance of ACLs, or do I need to lecture you a bit more on that? Do we agree that ACLs are central to the access control model? Do we understand that very well? It is the ACLs that make, let's say, the domain admins the domain admins. Why? Because you would have a domain admin would have complete control over everything, over each of the object. So once again, do we understand? Are we good with ACLs? How important they are? Or do you want me to give you a couple of more examples? Okay, let me actually give you an example, an interesting one. But for that, I have to log on to the DC. Here we are on the domain controller. Now, if we look at the users and computers in this network, let's take a look at the ACL of the domain admins group. If you go to properties, security, and this and click on this advanced, the first tab that you see here, the permissions tab, this is the DACL or the DACL, discretionary access control list. Here you would see that, for example, if we look at this entry, this is an allow entry that allows system to have full control on the domain admins group. Okay, this is what a DACL is, a list of ACEs. The auditing tab that you see here, this is the SACL or SACL that logs success or failure for actions on this object. Make sense? Now, how is ACL important for an attacker? Other than the chart that we saw here, that shows us what is it that can be done by using ACL, let's take a look at a very simple example to make it even more clear. So there was an era like 20 years ago, for example, where a way of persistence used to be, once you have domain admin, you add a user to the domain admins group. But that was like what, 15, 20 years ago. That's suicidal right now. So what you can do is just to take a look at how important ACLs are. In place of adding your user to the domain admins group, you can actually add an entry here. Let's say a user that we control, for example, student one. We can actually provide student one full control over the domain admins group. So now we are not a member of the group, but what does this full control mean? If we have generic call, let's say on a group, you can add or remove members, add ownership, reset passwords, uh, and or grant ownership. So at least these two, add or remove members and reset password of members. Now this is interesting. What does that mean? That means that we can now go ahead and reset password of the default domain admin and SVC admin, or we can add or remove a user from this group if we have the credentials of student one. That is how powerful ACLs are. The user student one will not show up as a member of domain admins, but it would still control the group. Make sense now? Will it also be visible in Bloodhound this way? Yes, that's a very good question actually. So yes, if you run Bloodhound ingester now after making this change, then you can go to the, if I've not closed it, yes, I've not done that yet. So for example, if we now look for the domain admins, assuming that you run the ingesters after that, you look at the domain admins. Okay. You look at the domain admins and look at the inbound object control. So that would show you who has control over the domain admins group. A question is, how do we know that if a user has, let's the student user has these rights, the outbound. Here we are looking at inbound. Look at the outbound controls. So inbound is who has control on me. Outbound means where do I have control? We looked at this if you recall. Student one is a member of RDP users that has many interesting roles. All right. Now, before I answer any questions, do you think that this is a valid persistence mechanism? Do you think that this is a valid persistence mechanism, adding an ACL to the domain admins group? Yes or no, and why? Why do you think it is a valid one or not? No, as it might trigger a detection. Oh, okay. MDI will detect the changes. I wish. Yes, the correct answer is SD prop. So there is a sanitization mechanism on the domain controllers. Literally SD prop, security descriptor propagation. So there is a set of high value groups called the protected groups. Every 1 hour by default. There is a special container called admin SD holder. The ACL of admin SD holder overrides ACL of all the protected groups and their members. So this is not a valid persistence mechanism, however, pretty useful to understand the power of ACLs. Okay. I hope now we understand, now we know and appreciate ACLs. So how do we get it from the command line? So we can use power views get domain object ACL, or as we saw, we can use Bloodhound's collectors to collect it and uh, analyze it later on. We can even use the AD module for that. So for example, we can simply run get domain object ACL from power view. We can run it against a name or a prefix or even a distinguished name. So you can run it against an entire range of objects, and you'll get the ACL. Everything has an ACL in Windows. Whether it is the domain object itself, whether it is services, everything has its own security descriptors, which command how do you access it. Sorry. All right. Now, it is cute, it is nice to list these, but there are literally thousands of ACEs in any production environment. Okay, so how do you find out the abusable ones? One way, of course, is to use find interesting domain ACL from PowerView that lists all the ACLs where someone has, let's say, generic write or modify permissions. However, it is specifically this case where Bloodhound trumps everything else. It is so convenient to look at ACLs here. You could literally be whistling while you analyze this. That's okay. Student one is a member of RDP users. RDP users has a generic all on a user called control2, a user called support2, another user called control1, and support1. It also seems to have enrollment rights on an ADCS template and another one. Not only that, it also has generic all and generic write on a group policy called AppLocker. We also get to see that student one is a member of domain users that has enrollment rights on couple of certificate templates. That's fantastic. That is as easy as it can get when it comes to ACL enumeration. Okay. There was a question about bloodhound.py, that is, how good is that? I've not tested it thoroughly, but I believe it is also a collector. So it would be equally noisy. It has nothing to do with if you're running it from Windows or Linux. It is the type of queries that you send. Okay, there is a comment that it is much slower. I mean, I've just run it for the sake of it. I've not tested it thoroughly. To be honest, I mean, if we talk about that, all of these open source tools are very useful when it comes to smaller environments. I once ran a Bloodhound ingester. There has been a lot of improvement, to be honest, after that, but I once run a Bloodhound ingester in a red team operation, like I believe it was 3 years ago, and it literally took hours to complete. It crashed once after 4 hours. Next time it worked, and it was guzzling up RAM like anything. I have to ask my customer to increase the RAM 2 times. Oh yes. I mean, uh, that's the thing with open source tools, and that is where I whenever we talk about in place of red and blue, when we talk about red versus blue, uh, the grass is always greener on the other side. As a red teamer, when I look at as a when I listen to blue teamers, they say that attackers need to be correct only once and defenders need to be correct all the time. No, that's not the case anymore. For them, it looks like an unfair world where an idiot can simply, fish another idiot and get into their environment. Uh, but if you look at it from the red team side, no, we don't have enterprise grade tools at all. I mean, if you compare, let's say, what is it? Of course, the costs are amazingly different, but if you look at what is it that the blue team has, what Microsoft Sentinel, that has a dedicated team of world's top developers. Okay, what do we have? A Python script that someone put together over a weekend when they were, high, probably high because of a substance or high because they were writing code. I mean, but they were high. So that's the kind of disparity that we have when it comes to tools in red versus blue. I mean, what is the best we have? There are some really nice tools. I mean, of course, let's say, for example, Cobalt Strike, Bloodhound Enterprise, Pink Castle Enterprise. There are some really nice tools, but still, if you compare them, for example, Pink Castle recently acquired. Pink Castle was maintained by just one guy, Vincent. That's it. So it is always a disparity. Grass is greener on the other side. I believe that blue teams get I mean, when was the last time when your CISO went to RSA and brought you back a shiny new red team operations tool? I would say probably never. A red team tool? No, they bring back a blue team tool. I was saying that if they bring a red team tool, they rarely would. So they would always bring the blue teams. I mean, of course, it becomes tiring after some time that, okay, oh yeah, another tool, another dashboard. But that's how it is. And it is not only that I have realized it, of course. You would see that there is now an entire industry of private red team tools. That is the reason. Detection, the kind of research that goes into that. All right. Question is, what about the BAS breach and simulation tools? I would not name anything, but yeah, they are fine. I mean, if you have deep enough pockets, if your organization has deep enough pockets, throw one in the mix that may actually give you some value. So, yeah, with all of this, let's wrap up this discussion on ACLs.